is this funny looking E thing, right? Some of you may have seen this in data handling before, in your statistics section before, but really we actually use sigma notation in our sequences and series. So when you are looking at sigma, now this thing over here is sigma. Sigma actually means the sum of. Okay, so all sigma is saying to you is add together. So what we are actually looking at when we talk about sigma is a series, the addition of terms in a number pattern. Now, sigma has three parts to it. Obviously, we've got the sigma sign. We have a number on top, we have a number at the bottom, and then we have an expression to the right. The number at the bottom tells us the first term from which we are adding. So for example, if this was, I don't know, n equals 2, this is telling me that I'm adding from the second term onwards. Okay, so term 2, term 3, term 4, etc., to however many terms we're told to add. The number of total terms we're told to add is given by this top number up here. So if let's say, for example, this top number was 20, this is telling me to find the sum of term number 2 all the way up to term 20. That's all sigma is saying to me. So the two numbers at the top and the bottom are telling me which terms to add. The expression that's given to us on the right-hand side is the expression for the series I'm working for. So this gives me the series nth term, that general rule as I've put there. So that tells me exactly which series I'm working with. Am I working with an arithmetic series? Am I working with a geometric series? What am I finding the sum of? So if we have a little look at an example of a series given to us in sigma notation, we've got this on the side here. So this is saying I want to add terms 1 to 4, and I know it's terms 1 to 4 because of the numbers at the bottom and at the top. There's 1 and there's 4. There's 1 and there's 4. Of the specific series, 4k minus 1. Now remember, this 4k minus 1 is our nth term. So this is the rule for the series that we are working with. And what we now understand, what we now know, is that I just need to add term 1 plus term 2 plus term 3 plus term 4 of the series 4k minus 1. That is all sigma tells us. Okay, so rather than me writing out in words, determine the sum of the first 20 terms of the pattern 4k minus 1, we write it in mathematical language. And I think this is what trips us up mostly when it comes to sigma. We don't really always understand what sigma is saying to us, which means that we struggle to answer the questions. But if we know what sigma is saying to us, the questions become a whole lot easier. Now, the sigma questions that you get asked in your exam are often the more complex questions. And I think they're only, this is my personal opinion, but I think we only consider them complex because of the fact that we often struggle to understand what sigma is saying or what sigma means. But if you know what sigma is saying to you, if you can look at an expression like that and know automatically, cool, I'm adding terms 1 to 4 of the series 4k minus 1, you are sorted, because sigma really is not too tricky if you understand what it's saying. Alrighty, so that is the basics of sigma. There's just one thing I want to point out here that I've put here that is going to become important a little bit later on, and I'll delve into it more a bit later. Sometimes we don't always start at term 1. So in the example here on the right, we started by adding term 1 and then term 2, etc., etc. I gave you an example here of n equals 2. We don't always start adding, or we don't always give you sigma where we start adding from the first term. I could ask you to start adding from the 7th term. And what that then means is we need to be very careful of how many terms we are actually adding. Now, if we want to know how many terms we're actually working with in our series, what we do is we take the top number minus the bottom number plus 1. So top number is obviously this value at the top. The bottom number is this bottom value. and then we add 1. Now, when we get to some examples, I will explain why that formula is true. We'll get to it, but it's just something to bear in mind in that we don't always start adding from the first term, and so then we need to be very careful of how many terms we are actually adding according to sigma. All right, is there any questions? I'm just going to stop here in case anyone wants to take a screenshot. Remember, if you do have a question, feel free to unmute yourself, or you can put it in the chat and I'll see it. But otherwise, we're going to have a look at an example. Okay. Right, so if we have a look at our first example, all we want to do right now is write the given series in sigma notation. Now, we don't often ask you to do this, and so we're only going to do 2 examples. But if you can convert from a series to sigma, it makes it easier to understand what sigma is saying to us. So there's a couple things that we need to know. If we do ask you to take a given series and write it in sigma notation, you will always assume that you are starting with term 1. So this is term 1, 2, 3, 4, etc., etc. And we need to know how many terms we're adding, because remember, according to sigma, we need to know the last term we add and the first term that we add. So I'm adding terms 1 to 6 over here. And so when I set up my sigma, I can already fill in what my top and bottom numbers are. So sigma, now guys, your sigma does not have to be perfect. I draw it like that. So I draw it like a sideways M. And even if you just do it as a sideways M, that's fine. And then I put like little shoes on the legs, but whatever. A sideways M is perfectly fine. Remember, the bottom number is where you start. So we're going to start at n equals 1, the first term. The top number is where we end. So we're ending at term 6. And you don't have to write n equals 6 again. You've written it down at the bottom. That's fine. And we always write it down at the bottom because that's where we start. And then the next thing that we need on our right-hand side is our general term, or the end term. Let's actually say end term. Now remember, for me to find the nth term, I'm going to have to do a little bit of work before I can just write it down. The nth term here is going to be according to those formulas that we had a look at in the first 2 lessons, if I remember correctly. The first thing I need to do is I need to figure out what sort of pattern this is. So go and see what's actually happening. I'm adding 2 to 3 to get 5. I'm adding 2 to 5 to get 7, 2 to 7 to get 9. And so what I see is that I have this constant first difference. And so that therefore means I'm working with an arithmetic series. That therefore means that Tn is equal to A plus n minus 1 D. So because I know my formulas and because you have the formula sheet, you know exactly what it is you're working with. And now we can go and work out what Tn is. Now remember, A is your first term, so that's 3. Plus n minus 1 times your constant difference, which we've just worked out is 2. I have said this to you before, you don't have to simplify this, but obviously it makes life a little bit easier going forward. So if we distribute the 2 into the bracket, we get plus 2n minus 2. And so we get that Tn is equal to 2n plus 1, because 3 minus 2 is plus 1. That is now my nth term. So that is what I'm going to write on the right-hand side of my sigma sign, and that is what sigma is. If I want to take the series I was given and write it in sigma notation, that is exactly what I would write. Obviously, you wouldn't have the block on the nth term there. That goes away. But that is sigma. What we have done is we've taken the series and we've written it in mathematical notation. Okay, so writing the series in sigma really is not too tricky. And like I say, being able to put it in sigma notation really does help you understand what's going on when it comes to sigma type questions. All right, so guys, what I want you to try for me is example 2. So figure out what type of pattern you're working with, figure out the nth term, and then tell me what the sigma notation is. Again, you always assume that you start when you are given a series that you have to write in sigma notation at the first term. So here we're only adding 4 terms. Right, while you're doing that, if you do have questions, please obviously raise your hand, unmute yourself, ask away, or put it in the chat. But let's give the second one a try by ourselves. Okay. So can anyone tell me what type of series I'm working with here? Is it quadratic? Is it arithmetic? Is it geometric? What type of series have I got here? You can just put it in the chat if you don't want to raise your hand. Nice. It is geometric. Good. Okay, so this is a geometric series, which means that we are working with an R value. And remember, R is found by taking term 2 and dividing it by term 1. So in this case, R is 4. Now that we know that, we can go and work out what our Tn is. Remember, Tn for a geometric is a times r to the power n minus 1. This is the nice easy one because you actually have to do nothing. So we sub in our a value, which is 2. We've just worked out what r is. It's 4, and it's to the power n minus 1. That's it. There's literally nothing else we need to do. So now we can set up our sigma. So we've got our sigma sign. We're starting at term 1. We're ending our addition or our series at term 4. And then we write down the nth term for the series we've been given. And that's it. Right, so like I said, we don't get a lot of these questions. You get them more in tests, for sure. We don't get them so much in like finals and in exams and stuff, but being able to go between sigma and English, for lack of a better description of the series, it is really, really useful. So I'm just going to do this in case you want to take a screenshot. But our next example is going to have a look at how we actually now figure out the sum given a sigma expression. Alrighty, hope you've got your screenshots. Let's have a look. So if we have a look at this example, remember I said to you when we did our series questions, evaluate means calculate the sum of or determine the value of this series or the sum. So evaluate just means find an answer for me. So we've got the sum of, so sigma, remember the sum of k equals 1 to 10, 2k minus 6. All right, so a couple of things we want to figure out before we get started. Because of the number at the top and the bottom, so k equals 1 and this 10, we are adding terms 1 to 10. Now, obviously, guys, if you were really struggling, you could just go and substitute in n equals 1, n equals 2, n equals 3, all the way up to 10, and then add them together. But obviously the goal is that you don't do that and that you do work with your sum formulas. And especially because if you think of like last year's sigma question, it went up to 99 terms. You don't want to sit and sub in until 99. That's just time wasting and panicking. Right, so we're adding terms 1 to 10. That's based on the numbers at the top and the bottom. The second bit of information that we need to sort of take away from this is what series I'm working with. Now, we should be able to identify what type of series we have from our nth term. There's no n squared here, so it's not quadratic, sorry. There's no exponent here, so it's not geometric. This is just a linear expression. So we are dealing with a linear series. You want to say arithmetic rather, that's obviously absolutely fine. Now, the reason we have to know what type of series it is that we're working with is because that then will determine the sum formula that we use. So remember, the sum formula of an arithmetic series is Sn is equal to n over 2, 2a minus n plus 1 times the difference. Again, guys, this is on your formula sheet. You do not need to know this off by heart. It's on your formula sheet. But we do need to know what type of series it is we're working with so that we know which sum formula that we're going to. All right, so the first thing that we always do is sub in values. And in this case, it's of k. It could be of n, it could be of p. It just depends what variable they use to determine the first 3 terms. Now, sometimes we're nice and we ask you, or we scaffold our question and we'll say, determine the first 3 terms and then find the sum according to sigma. But if you can find the first 3 terms, you then just get a good idea of what's going on. And also remember that for both of your sum formulas, you need A, so you need your first term. Push comes to shove, if you only go work out your first term, that's also fine. But generally, 3 terms, you then get a rough idea of what's going on. You can double check your constant difference, your R value, and then you can go on from there. Right, so we want terms 1 to 10. I'm only going to work out the first 3 because I don't need to do all 10, and that's just going to be silly. So what we're going to do is we're going to substitute in k equals 1, k equals 2, and k equals 3. Now, guys, do this on a calculator. Don't try to do it in your head, especially because this is not the important part of the question. This is just to get your series that you have. If you do sub in there, remember, this will now give you term 1 should be 2 times 1 minus 6. I'm using the nth term I was given. And so your first term is -4. If we keep with the substitution, our second term is -2, and our third term is 0. Again, just do it on your calculator. You don't really need to show the substitution like I did here. You're more than welcome to, but you don't have to. But what it does now tell you is that you're saying -4, -2, plus 0, plus, and we're going all the way up to the 10th term. So now you know what exactly your numerical number pattern looks like. So now we can actually go and start with our sum formula. I did not leave myself enough space. I was clearly very optimistic here. Okay. Is what it is. Okay, so now we're going to go work out our sum. We've got our sum formula already. I wrote it down for us over here. And so now we want to work out the sum. Now, before we do that, we need to actually know how many terms we're adding. This is quite easy. You're adding term 1, term 2, term 3, term 4. It's 10 terms. But if you want to double check, remember n is equal to your top number minus your bottom number plus 1. That plus 1 minus 1, they're the additive inverses of each other. So they just give us 0. And so what we now know is that we're adding 10 terms. So the sum of 10 terms is equal to 10 over 2, open bracket 2 times a. Now this is why we needed to sub in our values of k, because we needed to know what a is. It's -4. Plus n, which is 10 minus 1 times D. Now, grade 12s, we should remember this from like grade 8 and grade 9. Our D value, so this difference value that we have here, is actually the coefficient of your variable. If you're not sure, obviously having the first three terms allows you to figure out what D is. So from -4 to -2, we added 2. From -2 to 0, we're adding 2. And so this is why I'm saying it's actually the same thing as the coefficient. If you didn't know that, it's a really useful trick to know. But now we know that our constant difference is 2. Right, and then obviously remember, once you've got all of that, you chuck it into your calculator and you get an answer. So I'll give you 10 seconds, put that into your calculator and tell me what the sum of your first 10 terms are. You can obviously put your answer in the chat, but if you do have an answer and you want to unmute, feel free. What is the sum here? We're just substituting this into our calculator. Okay, now guys, remember, we're adding -4, -2, but then we're going up into positive. So our sum should be a positive answer. Nice, guys. So the sum of our first 10 terms is equal to 50. Those of you that didn't get 50, just double check your substitution. But like I said, it should be positive because you've got only 2 negative values in your series. All of the others are positive. So we should get a negative answer. Alrighty, that's it. We've got the sum. We've worked out what we needed to. This is what sigma is saying to me. So like I said, I do understand that sigma is confusing and we don't always understand what it's asking of us. But once we get it, I promise you things become so much easier. Right, so I'm just going to wait here, take your screenshot, and then we're going to have a look at another one that deals with a geometric sequence, which I've given away now, but it's fine. It is what it is. Okay, nice. So let's have a look at sigma in a geometric space. So here we've got, as you notice, a different variable, which doesn't really matter. Variable is just a placeholder for an unknown. So we've got I equals 1, and we've got 8 at the top. So this tells me that we are adding terms 1 to 8. For the first 8 terms. The next thing that we see is that we have, whoopsie daisies, we have got our nth term over here. And because of this exponent, because I is now in the exponent, I know that I'm working with a geometric pattern or geometric series. Right, again, it's important to know what type of series it is that we're working with because this tells us what our Sn is. So remember, for a geometric series, the sum of n terms is equal to a times r to the power n minus 1 over r minus 1. Again, this is on your formula sheet. This is not something you need to learn off by heart. It's on the formula sheet. But obviously, it's all very well of being on the formula sheet. We actually have to know which formula is which. But this is the sum formula for our arithmetic sum or series. So what I want you guys to quickly do for me is work out the first 3 terms. So remember, we're going to substitute in our I value. So we'll sub in I equals 1, I equals 2, I equals 3 to get our first 3 terms. You can just put them in the chat once you've got them. But let's figure out our first 3 terms for this geometric series. Nice, Morgan. Very so nice. Okay, guys. So once you substitute in, your first three terms are -10, +20, -40, and so you would keep going. Right, so we do actually know what our R value is because we can see it in the formula. Remember, this is A times R to the power n minus 1. So this is my R value, this is my A value. Now, obviously, the A value doesn't match up with what we've been given, but there's a lot of simplification that's happened. As you can see, the exponent isn't an I minus 1. So there is some simplification that's happened. So we don't need to stress that it doesn't match up. But the R value is, remember, your base. But again, if you're not 100% sure, that's fine. You've got the sequence. R is equal to term 2 divided by term 1. 20 divided by -10 is -2. So we can work it out if we're not sure. Now that we have that, we can now go and substitute into our sum formula and get the sum of however many terms. Remember, n is equal to your top number minus your bottom number plus 1. Again, additive inverse, they cancel each other out. N is 8. So we're looking for the sum of 8 terms. A in this case is -10. We've just worked out R to be -2, so be very careful when you substitute in. Please make sure you use brackets because it needs to be -2 to the power 8 minus 1 all over -2 minus 1. So I've said this before, but when you substitute, use brackets. It's going to make your life so much easier because it means that your calculator is registering everything as it should. So use brackets when you go and substitute. Right, Morgan is on it. I'm going to give everyone a second to see if they agree with Morgan's sum of 850. No, nice. So sub it in and tell me what your sum is. Nice, Mitchell. Dorinda, nice. Nice, guys. Amanda, very nice. 850 is our sum. Now again, guys, even though it's alternating between positive and negative, remember those positives are going to get a lot bigger. And yes, the negatives are going to get a lot bigger as well. But you're going to end, because you're ending on the 8th term, on a bigger, a bigger positive number than a negative number. And so what it means is that your negatives and positives should sort of not cancel out, but will even out to give us a positive value. But again, you're using the formula, you have all of the correct information because you've substituted in, you know exactly what your sum is because you've done it correctly. All right. So again, I'm just going to wait here for you to take a screenshot. And then we're going to have a look at an example that uses sum to infinity. Now, we did sum to infinity on Wednesday, so we know about sum to infinity. And sum to infinity can be represented using sigma. There's nothing wrong with it. Sum to infinity is asking the addition of. It's the same thing. Right, I assume we've got our screenshots. I'm going to move. Okay. Right, so if we have a look at C, we've got R equals 1 to infinity of 2 times 4 to the power 1 minus R. Now, please remember, infinity only happens with geometric series. It also only happens with geometric series where R is between -1 and 1. So this R value is maybe throwing us a little bit off, because it's not between -1 and 1, it's 4. That's much bigger than the range we want. But this is why it's so important to substitute to find your first 3 terms. Right, so what I want you guys to do is quickly find the first 3 terms for me. We know R is equal to 1. We know we're adding up to infinity. So we want to substitute R equals 1, R equals 2, R equals 3 to find our first 3 terms. So do that for me, and then we'll have a look at what we're dealing with. Again, I want the first 3 terms here. Nice. Morgan and I agree with you. Very nice. Everyone another second or two. Nice. I like that we're writing it as a series. Chica, nice. Okay, guys. So exactly 2 plus a half plus an 8. Those are our first 3 terms. Okay, so like I said, the R value is probably throwing us off a little bit because it's not in that range, -1 to 1, that we know it should be when we are working with a sum to infinity. Because remember, sum to infinity means that your series converges on a single value. And so what that means is that your R value should be between -1 and 1. Right now, that's not happening, but let's go double check. R is equal to term 2 divided by term 1. Now a half divided by 2 is a quarter. Now if we go back up here, this negative R, remember negative exponent is actually a fraction. 4 to the power negative R is actually a quarter to the power R. So we do actually have the correct R value, and it was given to us here initially. It just doesn't look as we would expect it to. Because remember, things in maths can look different but mean the same thing. Equivalent ratios, equivalent fractions, LCDs, all of those things. So just because it doesn't look like what we expect it to, don't doubt yourself. Okay, just back what you're doing. All right, so we've got all of this. We now can go and work out our sum to infinity. Now remember, your sum to infinity formula is a bit different. The sum to infinity for a geometric series that obviously converges is A over 1 minus R, a much easier formula than the other one. So our sum to infinity, we know what A is because you went and found it for me. It's 2 over 1 minus a quarter. Remember those brackets when you substitute, and we can go find the sum to infinity. So I'll give you a second to tell me what it is. Okay, so someone's asked just in terms of the R value, what about the 1 in front of the R? So remember your geometric end term is Tn equals A times R to the power n minus 1. So that 1 is part of that expression of the original exponent. But what we can see is that they've switched. So instead of R, instead of n minus 1, it's now 1 minus n or 1 minus R. And that has to do with the negative exponent. If R was raised to a negative, and we then were to distribute that in, that would give us R to the power 1 minus n. So that 1 is also part of the whole negative exponent idea, or the fraction R value, and the 1 comes from the original Tn. It doesn't affect anything, that 1. Obviously, when you substitute in to find your first 3 terms, we have to remember it. But it's just coming from the negative exponent that we started off with. So I hope that makes sense. If it doesn't, obviously just let me know. But I'm loving the sum to infinity that I'm getting in the chat. Your sum to infinity is 8 over 3. If you wanted to write it as a decimal, I don't actually know what it is as a decimal because I don't like decimals. 2,6 recurring, or 2,67 if you round off to 2 decimal places. But remember, I said to you guys that the second you round off, it's inaccurate. It's all of a sudden an estimate. So try and leave it as a fraction as far as possible. Right, but that's essentially sigma. So what I want to have a look at next is what happens if I asked you to find sigma that doesn't start at the first term. So what happens if that bottom number is not 1? But take a quick screenshot of this, and then I'll scroll down to our next examples. And grade 12s, remember, please, if you do have questions, unmute yourself or put it in the chat. You can see I'm dealing with questions as they come through. I know this sigma can be quite confusing, so please rather just ask and make sure that you're feeling comfortable rather than just leaving it. Okay, so let's have a look now, like I say, if we're not starting to add from the first term. So if we have a look at the situation over here, we've got sigma, but now what we need to be very, very careful of is this bottom number is not 1. My bottom number all of a sudden is 3. So I'm adding from the third term to the 10th term. Now let's not say it's a problem, but we now need to be very careful with what we're doing. So I'm no longer adding term 1 plus 2 plus 3 plus 4. I'm only saying 3 plus 4 plus 5 plus 6 plus 7 all the way up to term 10. Now, whilst it might seem problematic in our heads of, oh crap, what do I now do? We don't overthink it, right? So all you now need to think of is adjust your viewpoint. Think of term 3 as now the first term that you're going to add. So what I mean by that is when you now go and find those first 3 terms, there is no point of finding if k equals 1, if k equals 2. What is the point of doing that if I'm only going to start from k equals 3? So what we're going to want to do here is we're going to substitute in for k equals 3, k equals 4, and k equals 5. Those technically are the first 3 terms that I add in the series. Yes, it's term 3, term 4, term 5, but I'm only starting my addition from term 1. So there's no point in stressing about term 1 and term 2. They don't feature here. They're not important to me right now. So we would only substitute from where k starts for the first 3 terms. So if we quickly do that, this would give us, let's not do that. This would give us a series, excuse me, that is 19 plus 24 plus 29, and so we would keep going. That's just me substituting in. So 5 times 3 is 15, plus 4 is 19. 5 times 4 is 20, plus 4 is 24. 5 times 5, 25, plus 4, 29. So that's my series. Yes, it's term 3, but I only want to start adding from term 3. Now, Amanda's put there on the chat 10 minus 3 plus 1, which is where we want to go next. So yes, I'm adding term 3 to term 10, but how many terms is that actually? So remember, right at the start, I said to you, if you want to know how many terms you are adding, so your n value, in this case, your k value, doesn't really matter, but how many terms are you adding? We take the bottom number minus the top number. Let's maybe go the other way. The top number minus the bottom number plus 1. So 10 minus 1 is 7. 10 minus 3 is 7. 7 plus 1 is 8. So what this is telling me is I'm adding 8 terms. Now let's just discuss why this formula is true. What we often forget to do is we'll just say 10 minus 3. 7, that's how many terms. But we often forget to count the first term. So I'm adding term 3, 4, 5, 6, 7, 8, 9, 10. That is 8 terms that I'm adding. Yes, 10 minus 3 is 7, but we're not then including our first term, or sometimes we forget the last term. And so this is why this formula works. It makes sure that we are including everything that we need to add. So we're adding 8 terms here. This is an arithmetic series because there's no exponent, there's no squared. This is just a basic arithmetic series, which means we need to use the arithmetic sum formula, which is Sn is equal to n over 2 times 2a plus n minus 1 times the difference. Okay, now again, remember I said this to you earlier, the difference is actually the coefficient of your variable. If you don't believe that, just go and work it out. 19 to 24 is an addition of 5. 24 to 29 is addition of 5. That is your constant difference. Right, so guys, quickly work out for me the sum of these 8 terms. I'll do the substitution just so that we know what we're doing. Now remember, your A value is the first term that you add. So this 19 is your A value. Oh, we're getting a mixed bag of answers here, guys. Double check your substitution. I have written it out there what you should be substituting. Remember, 19 is the first term that you are adding here. Nice, grade 12s. Okay, so exactly, the sum of these 8 terms, so term 3 to term 10, is 292. So those of you that didn't get it, just double check your substitution. And like I say, just remember that even though we're starting from term 3, that is the first term that we're adding. So that will be our A value. Okay, I'm just going to wait for you to take screenshots. If you have any questions, obviously, by all means, ask. Okay, so let's have a look at another one. So if we have a look at question B, we've got the sum of k equals -2. Now that also doesn't really make sense because we know that our n values, or the number of terms that we work with, are natural numbers, but it doesn't change anything that we do. We don't need to get bogged down by it. We're just going to substitute in what we should always substitute in. All the way up to the 6th term, and we've got 2 times 3 to the power k plus 2. Alrighty, so like I say, we're not going to change anything that we've been doing. We don't need to get confused by anything. We have the steps that we should follow, so that's what we're going to do. We've got k equals -2 all the way up to 6. So I'm going to substitute in for k equals -2, k equals -1, sorry, and k equals 0. I'm just going to move up from there. That will be my first 3 terms. Yes, logically, we know that the position of our term should be a natural number, but here we've been told to start at -2. So that's what we're going to do. We're not going to question it. We're not going to worry about it. That's where we're going to start because that's where we need to start adding from. So if we do that, we get that our sequence is 2 plus 16 plus 16, 6 plus 18, and so we keep going. This is just through substitution. So it would be 2 times 3 to the power -2 plus 2, that's to the power 0. 2, anything to the power 0 is 1, so 2 times 1 is 2. And so you keep going. Just substitution to get your first 3 terms. Right, once you have that, if you want to double check your R value, because we can see this is geometric because of this exponent, we can double check our R value. So R would be equal to term 2 divided by term 1, so 6 divided by 2, which gives us an R value of 3. That does match with what we've been given, so we're not too stressed there. We do not need to figure out how many terms we are actually adding. Remember, n is equal to the top number, so 6, minus the bottom number, so -2 plus 1. Now, grade 12s, remember, when you've got this negative situation, you are actually adding. So we have 6 plus 2 plus 1, which gives us 9 terms that we are adding. Makes sense, right? We're going from a -2 all the way up to 6. So it should be more than 6 terms that I'm adding. And now we can go and find our sum. Remember, sum is a times r to the power n minus 1 over r minus 1. And we can substitute in what we need. So the sum of 9 terms is equal to, now remember again, your a value is the first term that you're working with here. So our first term that we're working with here is 2, where k is equal to -2. So that is our a value. So we sub in 2, open bracket, r is 3 to the power 9 minus 1 all over 3 minus 1. So don't overthink it. Don't stress about what you've been given. The -2, technically a pattern you can extend to negative infinity. We just don't work with them like that. But any pattern can be extended to infinity both ways. And we've seen this as we've sort of gone along here. So yeah, it doesn't necessarily make a whole lot of sense, but it is possible. So let's put this into our calculator and let's find the sum. Like that, I'm already getting answers. Well done. Nice, guys. Okay, so our sum of these 9 terms, okay, is 19,682. Alrighty, I'm just waiting in case anyone wants to take a screenshot here. And then I'm going to put one up that I want you guys to try by yourselves in these last few minutes. This hour has gone by so quickly. And guys, while you are doing that, can I just remind you that if your cameras are on, let's just be mindful of the fact that cameras are on. I don't mind if your cameras are on, but just be mindful of what you are then showing whilst your camera is on. Okay, so this is the one I want you to try by yourselves. We're adding only from the 5th term, but we're adding to infinity. So again, don't overthink it. Work out the first 3 terms. You know your sum to infinity formula. Off you go. So I'm going to give you a few minutes. Remember, ask questions if you have any as you go along. I'll give you another minute and then I'm going to go through the answer. Oh, grade 12 is amazing. Well done. You're still busy? Like I say, I'm going to give you another minute or so. Like the answers I'm seeing so far though. Very nice, grade 12s. Awesome. Okay, so let's have a look. So we've got our I value. We would sub in I equals 5, I equals 6, I equals 7 to get our first three terms. Those first three terms then are 3, 1, oops, maybe let's write this as a series, 3 plus 1 plus a third, and so on. What that then means that our R value is a third. Again, yes, the base is 3, but that's a negative I. So it implies that it's a fraction that we're working with. But again, because you've got the terms, just double check. There's no harm in double checking. So we have all of this. Remember, your sum to infinity formula is A over 1 minus R. This R value, remember, we always just like to make sure it does fall in the range that we know it should for a converging series. So that's sum to infinity converging on the value. And so now we sub in what we know. So remember, your A value is 3, even though it's I equals 5, that is the first value we're adding. 1 minus R, so 1 minus a third. And then when you go and put that in on your calculator and you do all of those things, you get that your sum to infinity is 9 over 2. Avoid writing it as 4.5. Like I say, just keep it as a fraction. Makes life so much easier. But there we go.